right, Unit 3, final exam review. Choose the best answer. Which of the following statements is or are always true? That tells you there could be more than one answer. If you ever see something like this, it tells you that you possibly have more than one answer. Don't know what happened there, a little delay. There we go. Okay. So, if two triangles are congruent, corresponding angles are congruent. Okay? So, if you have two triangles that are exactly the same, do the angles match up? That is true. You can prove two triangles congruent if you know that three corresponding angles are congruent. Okay, after the last chapter we just studied, this gets back to AA similarity, but not congruency. You cannot prove congruency that way. If two triangles are congruent, one of the pairs of congruent triangles must be right angles. No, you can have congruent triangles that are not right triangles. The three interior angles of a triangle add up to 360 degrees. No, they do not. They add up to 180. So in this one, it's just A. Which of the following statements is false? Pay attention. It says false. If A, B, C, D, E, F. So remember the trick we showed you. A, B, C, D, E, F. Write them over each other and then look. A, D. Nope, that's true. A, B, C, D, E, F. That's true. Angle and triangle. AB, so here's AB, EF. Are those the same? No, they're not. So that's our answer. BC and EF are. Which of the following is not a way to prove triangles congruent? Well, there it is. It's spelled backwards, but we know we do not have that rule. SSA or ASS. When do you use CP-CTC? Remember, that stands for corresponding parts of congruent triangles are congruent. A is wrong because CP-CTC can only happen after you've proven them congruent. To prove that a third triangle is congruent to two other triangles. Nope, never done that. To prove that corresponding parts C, P, C, T, C. Well, that's the definition of it. And before you prove, again, it's afterwards. All right. SAS, what does it stand for? It stands for side, angle, side. Now, how do we mark that? There's a multitude of ways. Side, angle, side. As long as the angle is in between, the angle is formed by the two sides we mark. This one is side, side, side. So, side, side, side. ASA means angle, side, angle. So we mark an angle, we mark a side, and then we mark the next angle down that line. AAS, angle, angle, side. So we mark an angle, we mark the next angle. Let's go this way for once. And then we mark the next side after that. HL, that stands for hypotenuse. I spelled it wrong. SE, leg. So remember, this is always a right angle. Has to be. And then the hypotenuse has to be the same, and either leg has to be the same. And that's it. Okay, use given information to see if they're congruent. Okay, M is 90. Boom. Well, that didn't go well. M is 90. D is 90. MN is congruent to DY. ON is congruent to AY. Okay? Well, if you look at it this way, this is ASS. We don't use that rule. But, since it's a right angle, we do have the hypotenuse and the leg. So, remember, HL is a way to get around ASS in right triangles often. So, ONM. So, writing down the hypotenuse, coming back towards the right angle. So, writing down the hypotenuse, coming back towards the right angle would be AYD. And remember, order matters. ADY would not be correct, especially if it's on a multiple choice test. Be careful. First thing we have to do here is mark the same side. And now we have S, S, S. So, RSC. So, starting here, Highway 2, Highway 3, Highway 1. So that means starting here, Highway 2, Highway 3, Highway 1, KCS. Okay, C is the midpoint of MJ. That means this piece is equal to that piece. It's also the midpoint of KP, which means this piece is equal to this piece. And we know we have vertical angles here. So we have side, angle, side. So MKC. So no name highway, Highway 2, Highway 1. No name highway, Highway 2, Highway 1. JPC. And all these little tricks, all the extra writing, helps you get it right if you take the time. First, we're going to mark this. Whoa! Board's really off today. We're going to mark this equal to itself. Now it says KLJ. K to the L to the J is this angle here. This can convert to MLJ. So MLJ right there. Then it says KJL, which is over here. This can convert to MJL, which is over here. And now we have side, angle, side. So JKL, starting at 2 to no angle to 1. Starting at 2 to no angle to 1. I'm talking about the markings. So JML. Okay, H and N are congruent. JM is congruent to LI. And that's it. We have an angle, and we have a side. And even though J and I look like right angles, we can't assume. And even if they were, we don't have the hypotenuse for HL, so this one is not possible. X is the midpoint of BC. AB equals DC. It's congruent. And we have vertical angles. So we have an angle, and then a side, and then a side. Not possible. No possible. Complete the following. Falcon. F-A-L-C-O-N. A-L is congruent to O-N. N-O-C. N-O-C. L-A-F. Sorry, the board's a little bit off. I got a new computer, so. F. Congruent to C. And LAF, well, we just did that one. Triangle and angle, the same thing, is NOC. These two are the same, just backwards. Solve the missing variable. Well, we know triangles add up to 180. So 47 plus 112 is 159. 180 minus 159, 21 degrees. This one, we know that all three of these add up to 180, so we can actually write that out, or we can just do it in our head. 3 plus 2 plus 1, remember that's 1. 6x equals 180. So 3x plus 2x plus 1x. Divide by 6, x equals 30. Now it's not 30 degrees, it's just 30. And this ends up being 30, 60, 90. Even though that doesn't look like a 90-degree angle. 2x and 3x should be switched. All right. We know those are the same. They're both x. We have $180 to spend at 3 stores. We spent $84 here. That means we have $96 left to spend. But we have to spend it equally at that store and that store, which means we need to divide it in 2. And when we do that, we get x is 48. And those are both 48 degrees. All right. Right here we have a linear pair. So 180 degrees in the linear pair minus the obtuse angle, 180 minus 137, means that x is 43. And then, how much did we spend at the 2 stores? 89 plus 43 is 132. 180 minus 132 is 48. And you can check that. 48 plus 43 plus 89 is 180 degrees. Okay, write a 2-column proof. This is going to be a little bit difficult with the board being the way it is, but we'll see. So R and U are equal, congruent. So we're going to mark those equal, congruent. S is the midpoint of RU. That means this is equal to that. And we know we have vertical angles here. So what do we have? Angle, side, angle. Yep. Easy enough. So we're going to first say that angle R is congruent to angle U. And S is the midpoint, we can abbreviate to save space, of RU. Given. Remember, all you have to do is take this and write it here. And this is the reason. That's all you do is copying. And this has to be our last line. So I can even write that right now. Triangle VRS, that's an R, not a B, is congruent to TUS. And we know it's going to be ASA. We see that in our drawing. So we got 2 things missing. Okay? What did we say? We said that angle 1 was congruent to angle 3. How do we know that? Definition of vertical angles. And yes, we were told the midpoint, but we marked RS congruent to US. Apologize, the board being off. RS and US. How do we know that? Definition of midpoint. So we just have to justify what we wrote over there, and we're done. That's all there is to it. Notice, we're proving a part. This is going to go down here. MK has to be congruent to RK. I'll give you a hint. We already know the only way to do that is with CPCTC. We can start at the ending and come back. And then we just copy this here. GM is congruent to RG. Let's mark that. GM congruent to RG. Angle KGM is congruent to angle KGR. KGM is here, KGR is there. How do we know that? They told us, it's given. Now, what can we mark? We know that KG is congruent to itself. And what is that property? When you look at yourself in the mirror, you see your reflection. It's a reflexive property. And now, before we can do CP/CTC, we need to prove the triangle is congruent. Can we do that? We sure can. By SAS. So we just say, now look, we just copy this and put a triangle mark. Triangle KGM is congruent to triangle KGR. It's the same statement, just triangle instead of angle. And we're finished. And that's it.